In this video, we're going to take a look at some derivative rules, and we will prove the product rule. All right, so let's take a look at some examples, or at a theorem. Suppose that f is a function from an interval I to r, and g is also a function from I to r, and those are both differentiable at this value c in that interval. Then if we have a constant in the real numbers, so if k is some constant in the real numbers, the function k times f is differentiable at c, and when we take the derivative of k times f at c, that is exactly the same thing that we would get as if we took the derivative of f at c and then multiplied that by k, right? So we can multiply it by the constant and then take the derivative, or we can take the derivative at c and then multiply it by the constant. Similarly, we have the function f plus g is differentiable at c, and f plus g, that derivative at c, is the derivative of f at c plus the derivative of g at c. Right? And so both of those things, I think you could do on your own. I think you should probably take time to practice those. See if you can roll through those. Use the definition of derivative to come up with those things. All right, let's now take a look at our product rule. So the product rule says the function f times g is differentiable at c. So if we know that both f and g are differentiable at c, then the product of those two things also has to be differentiable at c. The derivative of the product at c is not the product of the derivatives. It is f at c times the derivative of g at c plus the derivative of f at c times g at c. So let's go through and prove this. So here, to prove this, for every x and I, so for each x and I, we have, with x not being equal to c, we have f times g of x minus f times g of c over x minus c. This is equal to f times g, right, so this is f of x times g of x. This portion right here is f of c times g of c. We're going to just throw in here some stuff in the middle, right? And so that stuff in the middle, so I have space. That stuff in the middle, we're going to add in and f of x g of c, and we are going to also subtract out f of x g of c. So we added in, we subtracted out. If we do that, then we can group together this piece and factor out an f of x. So we have f of x times g of x minus g of c over x minus c. And we can also group together the f of x g of c minus the f of c g of c. So we can group together those pieces and factor out the g of c. So we factored out the f of x and the g of c. Next, we make this observation that our theorem 6.1.6, right, so that was our theorem from last time. Right, if it's differentiable at a point C, then it's continuous at a point. So theorem 6.1.6 implies that f is continuous at C. So the limit of f of x as x approaches C is equal to f of C. And since f and g are both differentiable at C, since those are both differentiable at C, we conclude that the derivative of f times g of x is equal to f of c g prime of c plus g of c f prime of c. Right. And there, really what we've done is we've kind of looked at this piece. So that limit as x approaches c, this piece is going to f of c right down there. And the other piece, that is our definition of the derivative at c for g. And so that's where we get our g prime of c. And then we have the same general idea happening on the other piece. So g of c is a constant, and so that's just right there. And we have the limit as x approaches c for this piece is f prime of c. And so we have our product rule. The quotient rule, it is also true. So our quotient rule says if g of c is not equal to 0, then f over g is differentiable at c. And the derivative of f over g at c is g evaluated at c times the derivative of f at c minus f of c, f evaluated at c times derivative of g at c over g at c squared. Right? So it's the low times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Low d high minus high d low, square the bottom, and away we go. We also have theorem 6.1.10 says if I and j are both intervals, and f is this function from I to the real numbers, g is a function from j to the real numbers, and the range of f is a subset of j, and we let c be some element in the domain of f. If f is differentiable at c and g is differentiable at f of c, then the composition function is differentiable at c, and we have our chain rule there that we are familiar with. All right, that is all I have for you here. We will talk to you guys next time.